I am doing the chapter for class 11 science chemistry, some basic concepts of chemistry. Today is 19th of May 2021. It is the fifth period, time 11:20 a.m. to 12 noon. Today is the third day of the chemistry classes academic session 2021. Okay. Yesterday I had given you some work. I had given you to do some work
Yes, sir.
to find the number
Yes,
of
sir.
significant figures in the following constants. And here
Yes,
are the
sir. Yes, sir.
answers.
Sir, I did.
The first one is 6.626 into 10 to the power of minus 34. So the first
Sir,
answer
four
is
significant figures.
1, 2, 3, 4. Okay. Answer is 4 significant figures. The second one, 6.02 into 10 to the power of
Three.
23.
3.
It is 3. 6,
Sir,
0,
three.
it is 3. Answer is 3. The third one is 1.097 into 10 to
Four.
the power
Four.
of 5 per centimeter.
It's 4.
It is 4. 1, 2, 3, and 4. The fourth one is 5.29 into 10 to the power of minus 9
Three.
centimeter. It
3.
is 3. Okay. So the answer is 3.
Three.
So I guess all of you got these answers correct. Now, little
Yes,
bit of
sir.
extra
Yes, sir.
information I want to give you regarding these numbers. Look at the first number. The first number is a constant. It is called Planck's constant. You'll be learning this in physics also. It is called Planck's. It is called Planck's, P-L-A-N-C-K-S. It is called Planck's constant. What is it called? It is called Planck's constant. Okay,
Planck's constant.
Planck's constant. I'm writing the correct spelling over there. Okay, wait. It is called Planck's, P-L-A-N-C-K-S. Planck's constant. Planck's constant. It is a constant. It is known as Planck's constant. The second number which you see over there, 6.02 into 10 power 23. Have you seen this number before?
Avogadro's law.
It is not law. It is called Avogadro's number. It is called
Avogadro's number.
AVO, Avogadro's. Avogadro's number. It is called Avogadro's number. Okay. Look at the third number over there. 1.097 into 10 to the power of 5 per centimeter. This number is also a constant. It is called Rydberg. RYD. RYD BERGS. It is called Rydberg's constant. It is called Rydberg's constant. Okay. Rydberg's constant. The fourth number is 5.29 into 10 to the power of minus 9. It is 5.29 into 10 to the power of minus 9. It is called first. It is called first Bohr's radius for hydrogen atom, or an atom of hydrogen. The size of the hydrogen atom. Okay. So it is called the first Bohr's radius atom of hydrogen. Yes, somebody wanted to say anything? Yes.
So are you sharing a screen?
Yeah, I'm sharing the screen.
So but it's not showing over
So
here.
we are not able to see.
So isn't
Yeah, I'm sharing the screen. The screen is shared.
So we can't see it.
No, sir, we cannot see.
it's not visible.
We can't
So it isn't visible.
We
Now you
cannot
see?
see.
Can you see now?
Yes,
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 Can you see
sir.
now?
Yes, sir.
Can you see?
Yes, sir.
Okay, good.
Yes, sir.
Yes, sir.
Now, here are the answers for yesterday's homework. The first one is 4, second one is 3, third one is 4, and the fourth one is 3. The first number is a constant. It is called Planck's constant. The second one is also a constant number. It is called Avogadro's number. The third one is called Rydberg's constant. The fourth one is called first Bohr's atomic radius for an atom of hydrogen. Okay. Now today I would like to go further ahead in this chapter and talk about physical quantities and their SI units. physical quantities and their SI units. Okay. Now, in your lower classes in physics, you must have heard of basic SI units. Basic. Have you heard of basic SI units? Basic SI units. Basic SI units. Now, in the SI system,
Yes, sir.
the SI system has 7 basic units. 7 basic units. I'm just writing them down. The first one is called length. Length, its unit is
Lane.
meter.
So
Length. Length. The first basic unit is length. There are 7 of them. First one is length. The other one is mass. Okay, its SI unit is kilogram, kg. The other,
time.
then there is time. Time. Its unit is SI unit is second. Okay. The next one is temperature. The next one is temperature. Next one is temperature. And the SI unit of temperature is Kelvin. Capital K.
Kelvin.
Kelvin. Okay. Then the next one is amount of substance.
Mole.
Amount of
Mole.
substance.
Mole.
Mole.
Amount of substance. It is called, the unit is mole. We write in short MOL. Okay.
Luminous intensity.
Okay. Then next, yeah, there is also the luminous intensity is there. We can have one more before that. Electric current.
The electric current.
Current.
Electric current.
Mhm.
Electric current. Electric current is a basic unit. Okay, so electric current, its unit is what? Do you remember? Yes,
Yes, sir.
Yes, sir.
it is ampere.
Ampere.
And the 7th one is called luminous
Luminous intensity.
intensity.
Candela.
Luminous intensity. Its unit is candela. In short, we write it as small c, small d. Okay. Are you getting it?
Angular.
Huh?
Displacement.
No, these
Sir,
are the
angular displacement.
angular displacement. That is dependent on something, no? Okay, so we will not consider that under basic SI units. Okay. Now, after the basic units, no, there are other units which are called derived units. Derived. You must have heard of this in class 9 also. Derived units, fundamental units.
Yes,
So
sir.
here
Yes, sir. Yes, sir.
I'll be
Yes,
talking
sir.
about
Yes, sir.
derived units in this part of the chapter. Now, derived units are dependent. They are derived from other physical quantities. Please keep that in mind. Okay. There are plenty of examples of some common derived units for you all to remember. Like first one, I can talk about area. Area. You must have got area. Its
Yes,
unit
sir.
is SI unit is meter square. I am talking only about
Meter.
SI unit. Okay, System International. The other one is volume. Other one is volume. For volume, the SI unit, it is meter cube.
Meter cube.
Cubic meter or meter cube. Okay. The other one is velocity. Velocity.
Meter per second.
Velocity. You
Meter
can
per
write.
second.
Yeah, you can. You know that it is meter per
And
second.
acceleration
Okay.
also.
Then there is acceleration. Correct.
Meter
Acceleration.
per second square.
Acceleration is meter per second square. Meter per second square. Then we have density. We have density. The unit of density is SI unit is kg per meter cube. Okay. The next one is force.
Force.
Newton.
It is either Newton you can write or
kg meter
yes,
per second.
kg meter per second square. Kg meter per
Meter per
second
square.
square. Okay. After force we can have pressure also.
Yes,
We can
sir.
have pressure also. Okay, pressure also. Pressure, the units, SI units can be, symbol is Pascal.
Calories.
Yes, Pascal. Have you heard of Pascal?
Pascals.
Yes,
Pascal.
sir.
Okay.
Yes, sir.
And the unit is kg per meter per second square. Per second square. Okay. That is for pressure.
Yes, sir.
Then we have energy, joule, energy,
Yes, sir.
Energy
energy,
joule.
energy. The unit is joule. We recognize it as joule, or we can write kg, meter square per second square. Okay, that is for energy. Then we have frequency. Frequency. Have you heard of frequency? In
Yes, sir.
Hertz.
Yes,
Hertz.
sir.
Frequency, the SI unit is hertz. Hertz is cycle per second. Per second, or we can write per second also. Second to the power of -1. Okay, that is for
Yes,
frequency.
sir.
Then we have power. Power. For power, it is watts, joules per second. No? Remember? Power, you can write
Yes, sir.
either watts
Yes, sir.
or you can write kg meter square per second cube per second. Be very careful with this derived these units. Okay, these are very very important. Then we have charge. Charge is always for electric charge. No, so
For
uh,
Yes,
Coulomb.
sir.
For Coulomb.
yeah, charge is coulomb, capital C. So for charge, electric charge, we have capital C, that is stands for coulomb, or we can write ampere second. Yes, ampere second. Okay, and there is one more is there, potential, 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 electric potential. Okay, for electric potential we can write capital V. You must have done in class 10 in the chapter electricity,
Volt.
Ohm's law, under Ohm's law.
Volts. Volts.
Yeah, volts, we write capital V as volts also. Otherwise we write it in the other form also, kg meter square per second cube. Okay, or we can write over there amperes to the power of -1 per ampere. Okay, so these are the units which come under derived units. Okay, so when you talk about physical quantities, always keep in mind these two things. One is basic or fundamental, another one is derived units. Okay, so these are the examples which you should be able to classify when these are mixed together. Am I clear? Am I clear, boys?
Yes, sir.
Yes,
Okay,
sir.
Yes,
Yes,
now
sir.
sir.
the next thing I would like to talk about
Sir.
today is called dimensional analysis. It is called dimensional dimensional analysis. Now, what is the meaning of dimensional analysis? Now, whenever we need to convert one unit into another, listen very carefully. Whenever we want to convert one unit into another, then we always use a factor which is called conversion factor, isn't it? Yes or no?
Yes, sir.
Yes. Say for example,
Yes, sir.
if you are told to convert 1 kilogram, convert 1 kilogram into say milligrams. So what will you do? What will you do? You must know in 1 kilogram how many milligrams are there. No? Yes or no? So you are going to reduce this. The working
Yes.
is like this. 1 kilogram, it contains how many grams? Grams. 1000 grams.
1000.
1000 grams.
Yes,
And
sir.
we know 1 gram again contains 1000 milligram, isn't it? This is how you do the conversion. No, now again I can write the same thing as 1 kilogram is equal to, now I'm converting into milligram.
Kilograms.
So 1000 multiplied by another 1000, this will give me how many zeros are there? 1 2 3 4 5
Yes,
6
sir.
2. So can I write 10 to the power of 6 milligram now? Try to understand this.
Yes,
Okay,
sir.
or can I write 1 is equal to 10 to the power of 6 milligram, divide this by 1 kilogram. So this factor which you see over here, no, this factor which you see over here, this factor is called what? Conversion factor. Conversion factor. Conversion factor for converting converting kilogram into milligram. Did you get that? Try to understand. Go through the steps carefully. Okay. this part is very important, because in this physical chemistry, in this part of the chapter, there are many numericals which will be coming across. So we might need the conversion of one type of unit into lower quantity or higher quantity. So that's why it is very important for you all to able to work out the conversion of higher units into lower units or lower units into higher units. Okay. Now this was a brief introduction about dimensional analysis. Okay. Now I will give you one work for you all just now. Okay, so just now what you do is, I'm giving you one work, one question for you all to solve. Okay. Okay, now convert, write down the question, convert. Okay, say say 25 inches, 25 inches into centimeter. Try this, I'm waiting for you all. Convert 25 inches into centimeter. You may start, and I'll give you the hint over here. I'll give you the hint. If you remember from class 9 and 10, 1 inch is equal to how many centimeter? How many centimeter?
12.
Huh? No,
12.
no, 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 no. 12 inches.
2.54.
2.54. 2.54 centimeter. 1 inch is equal to 2.54 centimeter.
Sir,
So what is the conversion factor?
63.5.
Huh?
63.5.
63.5 centimeter.
2.54 divided by 1 inch, no? So this is the conversion factor, no? Yes or no?
Yes, sir.
So what will you do? You'll multiply this by 25, no? If you multiply this by 25, you will get the
So
answer in what?
25.
Yeah,
That
because you have to convert
is
25 inches,
centimeters.
isn't it? Yes or no? If 1 inch is 2.54, 25 inches will be 2.54 into 25. No? So how much are you getting? Tell me somebody.
63.5 centimeter.
63, yeah, 63.5. Exactly. Exactly, yeah, correct. Exactly centimeter.
Yes, sir.
So this is how you're going to convert. So that's why whenever you need to convert one unit, a higher unit into a lower unit, or this kind of sums, numericals, remember always to work out the factor, conversion factor. Okay, so this concept of conversion factor, it comes under dimensional analysis. Okay, now just for the sake of getting a better practice, I'm giving you the homework before I proceed to the next topic of the chapter today. Okay, I'm giving you a homework. Okay, so write down the homework first. Write down the homework first. You write down the homework. Okay, the homework is like this: convert convert the following convert the following into specified units. Convert the following into specified units. Number A, convert 100 seconds to ns. I'm writing ns. Ns stands for nanoseconds. Okay, nanoseconds. Okay, that is first one. Second one, today is 19th of May 2021. Okay, convert 100 seconds to nanoseconds. Number B, convert 60 kilometer to into meter. M means meter. Okay. Number C, convert 200 kilogram into milligram. Okay, mg means milligram, milli milligram. Number D, you have convert 1000 centimeter cube into into meter cube, okay. Number E, we have 1 pm. Pm stands for picometer, okay. 1 picometer into nm. Nm stands for nano, nano, nanometer. Then number F,
So can you please repeat the full form of PM?
pm I'm writing over here, okay. Pm means picometer, pico, meter, picometer. These words you have heard in class 9, okay. This picometer, nanometer in class 9, the first chapter is there, no. When I was teaching physics some days ago, okay, taught the students of class 9 about picometer, nanometer, nanosecond, all those things. Okay, so if you turn your physics textbooks from class 9, you will find over there these units over there. Number F. Number F is 75 grams. 75 grams into kilograms. Okay, and let me give you one more, last one. Number G. 50 micrometer. 50 micrometer into centimeter. Now this symbol over there, micro, it
So
is called
mu.
mu, micro, okay, micro, 10 to the power of minus 6, okay. So these are the homework which will make you investigate and find out Google, or turn back your textbooks from class 9 and make you turn the pages and find out what does nano stands for. Nanosecond means how much, milligram means how much, meter cube means how much, okay. So this is your investigative homework which I have given you, okay. Am I clear to all of you? Am I clear?
Yes, sir.
Yes, sir.
Okay.
Yes,
Now
sir.
I will of course definitely solve this homework in the next class. But before doing that, I would like to just proceed a little bit which I have left in the previous class regarding significant figures. Okay, I'm waiting. I think all of you have copied these questions A, B, C, D, E, F,
Yes,
G.
sir.
Okay. If you
Yes,
have
sir.
not,
Yes, sir.
if you have not copied, then I'll be sending this PowerPoint file in the WhatsApp group also, and I will be uploading it in the school's website also. So there is no issue about that. Okay, now have a look at the next slide over here. Till number 5 regarding significant figures I had done. Number 6, the non-significant figures in the measurements are rounded off. They are rounded off. Number A, if the most right digit is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. Now here I want to explain you one thing over here. Suppose there is a number. Suppose there is a number like this. I'm telling you the number. Please pay attention. Okay, please listen carefully. Suppose I write a number 5.6078. Can you see what I've written on the screen?
Yes, sir.
5.6078. And I ask you a
Yes, sir.
question.
Yes,
And I ask you a question. Okay, express this number. Express this number to 4 significant figures. 4. If I ask you the question, express this number to 4 significant figures. So if you see carefully, 1, 2, 3, 4. No. But after this fourth number, there is 8 over here. And this 8 is what? Greater than 5. No. Is it greater than 5? Yes or no?
yes, sir.
This 8 is greater than
Yes,
5. That's
sir.
why to write 4 significant figures out of this number, you have to write 5.60 to 7, you add 1. It becomes
8.
608. This is called rounding off. After rounding off, you write the given number up to 4 significant figures. Am I clear to all of you? Am I clear?
Yes, sir.
Yes, sir.
Okay.
Yes, Lord.
Now look at number B. Look at number B now. If the most right number is greater than 5, the preceding number is increased by 1. This is what I have explained just now. If the most right digit is less than 5, the preceding number is retained. That means There is no addition of 1 or subtraction of 1. Okay, so this completes your significant figures and your writing in scientific notation. Okay, now let us move ahead to the next topic in this chapter, which is called laws of chemical combination. Okay, now the chemical reactions take place according to the laws of chemical combination. All chemical reactions, they take place according to what? Laws of chemical combination. Now these laws will be discussed one by one, and while I'm discussing these laws one by one, I will be doing some numericals based on the particular given laws. So the first law of chemical combination, which you can see over here, is the law of conservation of mass. And this law of conservation of mass was given by the chemist Lavoisier. Antonio Lavoisier. Now the statement is like this: in a physical or a chemical change, the total mass of the products is equal to the total mass of the reactants. Okay, this law does not hold good for nuclear reactions. Important point to be noted over here. Okay, so this is the first law of chemical combination, which was given by Antony Lavoisier. Okay, in a physical or chemical change, the total mass of the products is equal to the total mass of the reactants. But keep in mind, this law does not hold good for nuclear reactions. Am I clear? Am I clear to all of you?
Yes, sir.
Now,
Yes, sure.
now law of conservation of mass. Law of conservation of mass. Now, one of you tell me what is law of conservation of mass. I want to listen from you.
The energy can neither be created
No,
nor
no,
be
no, no,
destroyed.
no, no, no. What did I state just now? Just now I stated something else, and you are saying your own answer. What is law of conservation of mass? One of you say.
So
When there is a chemical change, the total mass will remain the same.
In any chemical reaction, the total mass of the reactants is equal to the total mass of the products. That is what I mean to say by law of conservation of mass. For example, if you take the thermal decomposition of a compound, which is calcium carbonate, this calcium carbonate, upon subject to high temperature, it will undergo thermal decomposition to give calcium oxide and liberate carbon dioxide gas, provided the reaction is carried out in a closed chamber. If the reaction is carried out in a closed chamber, this carbon dioxide gas which is formed, it will not escape. Now, if we work out the mass of the reactant and total mass of the product, we will find that they are same. The total mass of the reactant, that is left hand side and right hand side, the total mass is always same. This is called law of conservation of mass. Now, you know calcium. Does anybody remember what is the atomic mass of calcium? Yes? How much?
40.
Huh?
It's a 40.
Now look at this. Calcium, it is 40. Carbon is 12. Oxygen is 16. 3s are 48. Are you getting it? Are you getting this?
Yes, sir.
Calcium is
Yes, sir.
40, one atom. Carbon is one atom, so its atomic mass is 12. Oxygen is 3 atoms, so its atomic mass is 16. 16 multiplied by 3 is 48. So if we add this, it is coming to 100. And if I put G over there, the gram molecular mass of calcium carbonate is 100 grams. On the right hand side, the product side, if you see, if we add the masses of calcium oxide 40 plus 16, it becomes 56 grams. And for carbon dioxide, it is 12 plus 32, that is coming to 44 grams. Just check. If we add this 56 plus 44, again you will get 100 grams. Thus proving that law of conservation of mass is holding good only when the reaction is carried out in a closed chamber. But keep in mind always that the law of conservation of mass does not hold good or does not hold correct for any nuclear reactions. Am I clear? So in the next class, my dear students, I will first check the homework which I have given you, and then I will do problems. Remind me, I will do problems in the next class. Some problems based on law of conservation of mass. Am I clear? So now whenever you happen
Yes,
to
sir.
watch my videos
Yes,
on the
sir.
YouTube channel,
Yes,
please make
sir.
sure you subscribe to my videos. Okay? Then whenever I upload the videos on YouTube, you will immediately get the notification. That way it becomes easier for you also. Okay, now my dear students,
Already subscribed.
I would like to I would like to end my class here only. Okay. Before ending the class here, I want to take the attendance before going. I have taken the attendance in the beginning already. Now I will take the attendance before leaving the class. Please hold on, be there only. Don't leave the class. Okay. Attendance list. It is downloaded. Okay. It is downloaded. I have done it just before you only. Okay. I have stopped sharing the screen now. Now I am leaving the class. Now you may go for your lunch. Thank you, boys.
Okay.
Thank you,
Okay,
sir.
sir.